Okay, Algebra 1, Unit 6, Part 9. Modeling exponential growth and decay. Okay. Write an exponential growth function to model each situation. Determine the domain and range of each function, then find the value of the function after the given amount of time. Okay. Number 1, annual sales for fast food restaurant are this, and increasing at the rate of 4% per year. And then we need to figure out the value of after 5 years. Okay. So increasing, that's a growth function. So we're going to, how do I figure out the function? So y equal to a times b raised to the x power. That's the growth function. Oh, no, exponential function. Okay. 650,000, that initial value, right? Initial value, which is a. Increasing at a rate of 4%. So b is going to equal 1 plus 4%, 4 divided by 100. So we're going to change 4% to a decimal. So this equal 1 plus 0.04. So b equal to 1.04. 1.04 is bigger than 1. So this is a growing function. If the function is a decay, we just use 1 minus 0.04, minus the percentage. But for this one is a growth, so 1.04 raised to the x power. Okay, this is the function. Oops, let me erase them. Now we're going to figure out the function value after 5 years. So we're going to replace x by 5. So y equal to 650,000 raised to 1.04 raised to the 5th power. So I'm going to use a calculator to figure out the value of this part first, and then multiply this. So I'm going to use my calculator. So 1.04 raised to the 5th power, this equal to 1.21. And then multiply 650, 000. Okay, so the final value going to be 790,824. Point something, 0.38, but we don't have a half a person or the decimal, right? So this number have to be approximation, a whole number. 790,824 people after 5 years. If every year they grow like 4%, right? Let me double check. 1.04 raised to the power of 5, and then times 650, 000. Yeah, 790. Okay. Second one, the population of a school is 800 students, and is increasing 2%. Okay, so this is going to be 2%. So 2% is 2 divided by 100, so 0.02. Increasing, so y equal to initial value 800, and then we are going to use 1 add 0.02, so that is 1.02 raised to the x power. So now we're going to figure out the 6th year, right? So we're going to use y equal to 800 times 1.02 raised to the power of 6. So I'm using calculator. 1.02 raised to the power of 6. This equal to 1.126. And then I'm going to multiply 800. 901. Yeah. So after 6 years, the school going to have 900 students and 1, right? 901. Number 3, write an exponential decay function to model each situation, determine the domain, and the first 2 functions, we forgot the domain and the range, right? Domain and the range. The domain is what? Domain is the possible x value, right? X can be what? So the domain is all the possible x value. So domain going to be from what? From 1, right? Or from 0. X can be 0, but not negative. So it's from 0 to positive infinity, right? The range is R. R start from what? It's from 650, 0, all the way to positive infinity. With time going, if the population keep growing, right? It started from the smallest value is this, and keep growing. Range are all the possible y value, yeah? Second one, domain and range. So the domain is 0. Because number 1 and 2, both years, right? We can start like a year 0, but we don't have negative years. So the domain means x value, yeah? Range is from 800 student goes to the positive infinity. So this is number 1 and number 2. Sorry, I forgot the domain and the range. Okay, number 3, write an exponential decay function. Exactly the same thing as the number 1 and the 2, but 1 is a growing function, grows, and then this is decay. Decay means go down, right? Okay, number 3, the population of a town is 2,500 and decreasing at a rate of 3% per year. Okay, so the function going to be y equal to 2,500. What's going to be the number put here? So we're going to use 1 minus 3%. So 3% is a 0.03, yeah? So 1 minus 0.03, that's 9.97. I believe it's 9.97, right? 1 minus 0.003. Oh, 0. I made a mistake. It's going to be 0.97. So when the function is decay, the ratio is less than 1. Okay, raised to the x power. But here I'm going to change the x to the 5. Now I'm going to figure out the population after 5 years. So 0.97 raised to the 5th. This is equal to 0.86 and multiply by 2,500. So this is going to be approximation 2146 people. So the people are decreasing, right? After 5 years, the population dropped from 2,500 to 2146. Okay, what is the domain? Domain is the year, right? Started from 0, year 0, all the way to positive infinity. And the range are the population, or the y value, yeah? We start from 2. Oh, I should write from the small to big, right? What's the possible population, the smallest? Could be 0, right? Never never negative people, right? Population cannot be negative. So the smallest is going to be 0. And what is the biggest? It started from 2,500. So the range is going to be from 0 to 2,500 people. Yeah. So the highest value is 2,500. And the lowest, oh, no people here anymore because it's decreasing the population. Number 4, the value of a company equipment is 25,000. And the decrease at the rate of 15% per year, then 8 years. Okay. It's going to be 25,000 times, I need to figure out 1 minus 15%. 15% is just 0.15, yeah? So this is going to be 0.85. So 0.85 raised to the power of 8, because 8 years, so we need to figure out the 8 years. 0.85 raised to the power of 8, and then multiply 25,000. Wow, the value has become really small. So 6812. So every year, 15% value is gone. It's more than 10%, right? More than 10%. Wow. So the equipment, just like we buy a car, right? The value of the car, once you drive out of the car showroom, the value decreases. Someday it's not going to worth too much anymore. Okay, let's do the domain. Domain is all the possible value of the time, right? Start from 0 all the way to positive infinity. Many years. Okay, range. Someday maybe the equipment is going to be totally broke down. It doesn't worth anything. 0, right? The value is 0. The highest value, 25,000. So that's it. Okay, number 5, write exponential growth or decay function to model each situation, then graph the function. Number 5, population is this. Now, initial value is this. So this is A, yeah, initial value. Expected to grow at an annual, grow, okay, grow, I'm going to use 1 plus this. So 1 plus 20,000, 5%, that's 0.05, yeah? So this is 1.05 raised to the power of x. So now let's graph it. When x is equal to 0, the function, this part is 1. 1 times 2,000, 20,000 is 20,000. So when x equal to 0, it's right here. That's the first point, yeah? First point. What about when x equal to, let's do x equal to 2. X equal to 2, so 1.05 raised to the second power, and then times 20,000. So when x equal to 2, y equal to 22,050. Something like this, right? Right here. In fact, it's not, yeah, it's like this. And then, let me try 1.05 raised to the power of 10 years. And then multiply by 20,000. So when x equal to 10, the y value equal to 325.77. 325 25. It's a little bit above when x equal to 10. It's right here. So it's grow really, really slow. Something like this. Your graph can be a little bit different from mine. If you choose x equal to 4, x equal to 4, x equal to 6, x equal to 8. I try do it a little quicker, right? I use x equal to 0, initial value, and then 2, and then 10. So the graph look like this. Number 6, a boat that cost, this is going to decrease, right? Depreciating, that means the value go down. Wow, 20% per year, this is a lot. So the value after first year, only 80% left, right? So every year, 80% left, 80%. So 1 minus 20%, that is just 1 minus 0.2 is 0.8. So the value is, the function is 45,000 times 0.8 raised to the x power. So at the beginning, when you just bought it, the x equal to 0, not even 1 year passed yet. So the value is 45,000. 45. It's right here, right? This is 40,000. So above it, another box above it. And then year 1. So 45,000 times 0.8. So 36. Oh, at year 1, it's right here. What about year 2? When x equal to 2, the y value is 288. 288, something like that, a little bit below 30,000, right? What about x equal to 3? When x equal to 3, y equal to 23,040. 23. Something like this. Yeah, right here. Okay. Let me do maybe 8, or maybe let's try 10. 0.8 raised power of 10, and then multiply by the initial value 45,000. So when x equal to 10, that means 10 years. After 10 years, the boat only worth 48.31. Wow, that's, so here's a 5,000, right? So after 10 years, it's below 5,000. So the graph is going to look like this. I skipped at some point between 3 and 10. So the graph looks like this. I believe this part what? The unit 6, part 9. Part 9 is done. Part 9 is a real world situation.